morning, one and all. I am Dr. Ramya Shweta, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. Today, we are going to discuss what are the various, already in our previous session, in our previous lecture, what we understand, what are the various techniques, how understand the problem statement. According to that, which method we are choose for getting the desired soil property. We will understand those kind of things in our last class. In this class, we are going to understand soft clayey soil under a building foundation. So here we are going to construct the required construction work is building foundation. So our type of soil is soft clayey soil. Type of soil is soft clayey soil. Here the problem statement is a construction site has a layer of soft clayey soil. Soft clay has low bearing capacity, high compressibility and tends to undergo significant settlement over time under load. This makes it challenging to support structures like buildings, lead to differential settlements, crack and structural instability. So, once in the type of soil, because of this nature of the soil, we are not getting the desired soil properties. In each case, we may understand in this particular condition, the desired properties are bearing capacity, compressibility, and also settlement. These are and structural stability. So, these are the parameters which we are going to affect the building foundation. So, for getting the building foundation safe and economical, so we have to choose one technique for getting meet the required properties. Those are bearing capacity, high compressibility. So, here we are tend to do significant settlement over time. Under load also we are going to observe in these kind of soft clayey soil. So it is challenging to support structures like buildings. They are going to lead differential settlement, cracks and structural instability. So here how we are overcome those things in detail we are going to explain. Here soft clayey soils are characterized by the high water content, low shear strength and high compressibility. So, when subject to load such as building foundation, the soil undergoes consolidation where water is squeezed out from these pores leading to the settlement. The settlement is often uneven, causing differential settlement that can crack and damage the structures. This may happen because of the nature of the soil. So, once we propose the soil, once we propose any kind of construction work, based on the type of the soil, we are going to assess what are the properties are going to be affected. Because of those soil properties, what kind of elements are going to affected for this construction work. So, for not getting any kind of influence of these kind of properties not affecting the construction work, what we have to do? What are the techniques involved in that? So, for that purpose, we are understanding these ground improvement techniques. Here, the preloading with vertical drains. So, the preloading and vertical drains are there for understanding these kind of problem statement scenario. Here, so this preloading involves applying a temporary load, usually sand or soil on the ground before construction to induce settlement before the actual structure is built. This process compresses the soil and reduces further settlement. So, this preloading is help us to reduce the further settlement of the particular soil. So, because of this, we are choose this preloading with vertical drains technique. In vertical drains are installed to accelerate the consolidation process by allowing water to escape more quickly from the soil. These drains reduce the time required for preloading and make the site ready for the construction sooner. So because of these, it may took long time for getting the desired property. So in that particular case, we are choosing these vertical drains we are going to install to accelerate the consolidation process. So by allowing water to escape more quickly, so it means we are getting that site could be ready as early as possible. So in these, stone columns are also we may choose, that is in stone columns. One more. So here different types of in the problem statement, what are the problems we are facing, where we are going to rectify. In this, according to the ground modification techniques, various are there. In that, one is preloading with vertical drains and the stone columns. Here, the stone columns are constructed by drilling holes into the soft soil and filling them with compacted gravel or crushed stone. These columns act as reinforcement within the soil, increasing its load bearing capacity and also reducing the settlement. So using this technique for getting the desired properties, it increases the load bearing capacity and also reducing the settlement. The stone columns transfer loads from the structure to deeper, more stable soil layers. So these are stone columns transfer loads from structure to deeper, more stable soil layers. In this, the lime and cement stabilization is also one more kind of technique which may choose for this kind of problem statement. Here, adding lime or cement, it depends upon the properties of this soil, how they react with lime, how they react with cement. So these are the things for stabilization. So to this soft clay, chemically stabilize the soil. The lime or cement reacts with the soil, reducing its plasticity, increasing strength and lowering the compressibility. So once we require these properties, we are choosing these lime cement stabilization technique for getting the desired properties. So here they are going to reduce the plasticity, increasing its strength and lowering the compressibility. So in loose sandy soil to liquefaction. So in this is the issue. So soft clayey soil under building foundation, these are the availability techniques. Those are preloading with vertical drains, stone columns and lime cement stabilization are there. So as per the numerical and what kind of desired property we required, if you want the reducing plasticity, so according to that we are choosing, as well as the site requirement and the cost point of view, effectiveness point of view, we are going to choose the technique. Now, one more kind of problem statement we may observe, that is loose sandy soil prone to liquefaction. So a construction site is located on loose and sandy soil which is prone to liquefaction during seismic events. This liquefaction is a phenomenon where saturated sandy soil temporarily loses its strength and behaves like a liquid during an earthquake, leading to catastrophic failure of the foundations. So it leads to the failure of foundation. So loose sandy soil. So because of these liquefaction nature, we are going to understand these kind of because of the during the seismic effects. So what is liquefaction? It occurs in saturated, loose and sandy soils whenever the seismic shaking is happened. The shaking increases the water pressure within the soil, reducing the effective stress and causing the soil particles to lose contact with each other. This results in sudden loss of soil strength, causing the ground to flow like a fluid. Structures built on such soil can tilt, sink or collapse. So these are the issues we are going to face for these loose sandy soils whenever the seismic effects are there. So in this, we are having different kinds of techniques. Those are vibrocompaction, grouting and soil replacements are the techniques which these are the methods may adopt for reducing these kind of problem statement. In this vibrocompaction, It involves using a vibrating probe that is inserted into the soil to rearrange the sand particles into a denser configuration. This increases the density of the loose sandy soil, reducing its susceptibility to liquefaction. The process also improves the bearing capacity of the soil. So here we are going to understand in this vibrocompaction. Here the vibrating probe that is inserted into the soil to rearrange the sand particles. Here we are going to for getting the denser configuration. So in this increased density of the loose sandy soil, reducing its susceptibility to liquefaction. This process also improves the bearing capacity of the soil also. Bearing capacity. Now grouting. Permutation grouting. This technique involves injecting a grout mixture, example cement, chemical grout, into the loose sand to fill the voids and bind the soil particles. So in this, those bind soil particles together because of the choose of the grout mixture, whether it is maybe cement or any kind of chemical grout. So we are going to injecting those kind of materials. So the process in this also different methods are there. So according to the type of material we are choosing and requirement, we are choosing the which technique involves the injecting techniques we choose into the loose sand to fill these voids and bind the soil particles. So together this process increases the soil strength and reduces the risk of liquefaction. Here one more is the compaction grouting. So in this, high pressure grout is injected into the soil, displacing and compacting the loose sand around the injection point. This creates a more stable soil mass that is likely to liquefy during an earthquake. So as per the earthquake, whenever we are experience this, in this because of the seismic events, this liquefaction may happen. This liquefaction may happen. So in this we are going to choose this vibrocompaction or maybe grouting or any other because of the more stable soil may going to create during the earthquake. So here one more method we may choose, that is soil replacement. In some of cases, the loose liquefiable sand can be excavated and replaced with a more stable compacted material that is less prone to liquefaction. This technique is particularly useful in small areas where other ground improvement methods are not feasible. So this kind of technique is also we are choose because of the other techniques are it's difficult to, if they are not feasible in that particular condition, we are going to replace this complete soil. So liquefiable we use for in the using this liquefiable sand can be excavated, replaced with more stable. And one more kind of and one more, that is soil with high swelling potential. So soil with high swelling potential is our problem. In this, the construction site has expansive soil such as clay, which swells when it absorbs moisture and shrink when it dries out. So these kind of nature we may observe in our soil type. So according to that, the swelling and shrinking can cause significant damage of foundation, pavements and other structures. So in this, expansive soils, often clays, have a high content of clay minerals such as which has high affinity of water. When these soils get wet, then they expand significantly, exerting pressure on foundation and causing heaving. During dry condition, the soil contracts, leading to settle and cracking of the structure. So these kind of problems we may observe in our soil, in our ground improvement techniques. So using various techniques, that is chemical stabilization, soil replacement, moisture content control. So for this problem kind of type of soil, this problematic soil, for doing any kind of project, these are the things we are going to understand, that is chemical stabilization and soil replacement and moisture content. These are the three important techniques we may choose according to the requirement of that project. So in this chemical stabilization, we are using some admixtures or chemical, adding admixtures and chemicals are chemicals according to the requirement of the properties. This adding lime to expansive clay can reduce its plasticity and shrinkable potential. So once we adding the admixture, it reduces to these expansive soil, the nature which has, it is going to, whenever it is wet, it is going to shrink. Whenever it is dry, it is going to, so when it shrinks, when it dries out, and when it absorbs, it swells when it absorbs water, such kind. This lime reacts with the clay materials to form cementitious components, which stabilize the soil and reduce its swelling behavior. So in this clay minerals to form cementitious components, which stabilize the soil and reduce its swelling behavior. In cement stabilization, similar to lime, cement can be mixed with expansive soils to improve their strength and reduce swelling. The cement hydrates and binds the soil particles together, making the soil more stable. In case, in all possible, there is no all possible ways to choose this chemical stabilization. We may use in some of the cases that soil replacement also. In this soil replacement, in cases where the expansive soil layer is not too deep, it can be removed and replaced with non-expansive compacted fill material. This method eliminates the swelling potential of the soil directly to the structure. And one more kind of technique which may use for getting the desired things for this particular problem statement, that is moisture control. It may control based on the drainage systems or barrier systems. Depends upon the situations we are choosing. So here, installing proper drainage system can help control the moisture content in the soil, reducing the risk of swelling, ensuring that water does not accumulate near foundation, or pavements can prevent the soil from absorbing too much water. In this barrier system, moisture barriers, for example geomembranes, can be installed to prevent water from infiltrating to the soil, thereby controlling the moisture content and reducing the swelling. These are the things which we are going to understand in this particular problematic soil. So according to the requirement and possible conditions, we are going to choose among the techniques. In abatement on soft soil, in this kind of soil, problematic soil, an abatement for a road or railway is to be constructed on soft compressible soil. So the soft soil may not be able to support the weight of the abatement, it leading to the excessive settlement, instability and potential failure. So in this detailed explanation, soft soils such as clays and silts often have lower shear strength and high compressibility. When an abatement is constructed on such soil, the weight of the abatement can cause the soil to compress and settle over time. If settlement is uneven or excessive, it can be lead to cracks, deformation and potential collapse of the embankment. So for this kind of problem statement, we are having different kinds of techniques we may choose. Those are geotextiles and geogrids, prefabricated vertical drains, PVDs. So in this, and also controlled modules column and preloading with surcharge are the various things we are going to understand in this particular. These techniques may choose for this kind of problem statement. So here geotextiles are permeable fabrics that are placed between the soft soils and the embankment fill material. They help distribute the load more evenly, prevent mixing of soil with the fill and improve stability. Geogrids are similar to geotextiles but are made of grid-like structure. They provide reinforcement by interlocking with the soil and the fill material, enhancing the overall stability of the embankment. In this, PVDs are installed in the soft soil before constructing the embankment. These drains accelerate the consolidation process by allowing water to escape more quickly from the soil, thereby reducing time required for settlement. So, for reducing time, we require less time for settlement. This technique helps in achieving the desired soil strength before completing the embankment. In controlled modules columns, CMS are rigid inclinations that are installed into the soft soil to improve its load bearing capacity. The columns are constructed using a displacement agar that creates a void in the soil, which is then filled with a cementitious material. The CMS transfer the load from the embankment to deeper, more stable soil layers, reducing settlement and increasing stability. In preloading with surcharge, similar to preloading technique used for building foundations, preloading with surcharge involves placing additional temporary weight on the soft soil before constructing the embankment. This surcharge load induces consolidation and settlements of the soil, making it more stable for the final embankment constructions. As per the requirement and what are the parameters and the safety and economy project requirements based on that we are going to choose the technique for this kind of problem statement. So these are the some of the things we are going to understand in this particular module. We will see these kind of more in our next lecture. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.